Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, we are going to continue talking about, excuse me, eigenvalues and eigenvectors. But this time, or just to recap what we said, is we said for many matrices, there exists a vector called an eigenvector, such that if we multiply the matrix by this vector, we get another vector that has the same direction, meaning it's parallel to the original vector, but it has been stretched or shrank. So you either shrink it or stretch it, depending on the value of the eigenvalue, meaning the eigenvalue becomes the multiple or the factor that you multiply the vector by. So most of the time we stretch it, but I mean, it can be done so that it will shrink it, meaning it's a dilation operation. Nothing more, nothing less. But there exists a class of of matrices such that when you multiply it by that particular vector, it's not just gonna dilate it, but also it's gonna change its direction. So wait with me for a second and we'll show that. Let me show you a matrix. Use numbers that would make it easy. So I have a matrix here. Let's say 4, -3, 3, 4. This should remind you of something, but maybe we'll talk about it later today. This matrix, if you try to find its eigenvalues and eigenvectors, you should proceed as follows. You will say it's A minus lambda I. Take the determinant of that and equate it to 0 and solve for lambda. So you find the characteristic equation. The determinant is basically, this is the same as saying lambda minus 4 quantity square, right? So it's easy. We know that you get lambda square minus 4 lambda plus, 4 lambda, not 48. I'm losing my mind. Lambda square minus 8 lambda plus 16 minus -9, right? And that equals 0. So lambda square minus 8 lambda plus 25 equals 0. And when we solve for lambda, you can use the quadratic equation, -b plus or minus the square root of b squared minus 4ac over twice a. This is the square root of -36, so it's 6i. Divide these by 2, you get 4 plus or minus 3i. Okay, so these are the two eigenvalues. So when we say for lambda equals 4 plus 3i, what do we get? We substitute here. You get 4 minus 4 is 0, -3i, minus 3, 3, and -3i. When you multiply that by the eigenvector v1, v2, you should expect to get 0, 0. So the ratio of v1 and v2, you get -3i v1 equals 3v2, right? So now if we assume v1 is 1, then v2 would be -i. I, that basically is, I prefer to write I at the bottom. Many people use 1 for v2. And the reason I do it like that is that I want you to have the real portion on the top and the imaginary at the bottom, because that's how we usually write the x, y in a real and imaginary plane. So basically what we have here This is the real, this is imaginary. And my point, if I draw 45, well, it doesn't have to be to scale. So I'm just going to draw a line like that and say this point is 1 negative I. So this angle is pi over 4 over 40 or 45 degrees. Now, remember, when we had real eigenvalues, we would multiply the original matrix by that vector, and we end up with a multiple of that vector. However, this time, because in fact, if you do it, and then I will tell you what to do. So if you say 4 times 1, negative times negative is positive, and you get plus 3i. And here you get 3 minus 4i, right? However, notice that the I, we are only using it to differentiate between x and y. You can say this is the x and this is the y, but in that case, that can be written as 7 negative 1. Why? 7 negative 1. Why did I say that? Yes, because really the I here was like, we are using it just so we can plot, and we say that my eigenvalue and eigenvectors were complex numbers, not real numbers. Okay, but when you do the math to find angles and you found rotation, there is no reason to say 4. So this is it's as if this point is 1 negative 1 in the irregular xy plane. You see that we are in the fourth quadrant, y negative 1. And if I had written this as 1 negative 1, I would say 4 plus 3 is 7, and 3 minus 4 is negative 1. That's basically it. So I will end up at a point here, assuming this is 7, that looks like this. Or negative I, if you wish. So what is this angle? Well, easy. It's an angle whose tangent is negative 1/7. Well, we say negative 1/7 because we are in the fourth quadrant, but in reality, 1/7 would give you the magnitude of this angle, right? 1/7. So, oh my God, I was doing some work with, let me clear that. I should have brought the other laptop. Okay, so arctan of 1/7 is 8.13 degrees. Now, I want to show you something interesting. First of all, we said it's going to stretch and rotate. What did it stretch? Well, the stretch, this guy had a length of square root of 1 plus 1, which is root 2. This has a length of square root of 1 square plus 7 square, or root 50, or root 2 times root 25, or 5 root 2. So the stretching factor was 5. Do you see where the 5 is coming from? Yes. Look at the original matrix. 3, 4, 5. Pythagorean theorem. So if you take the square root of 4 square plus negative 3 square, or 3 square plus 4 square, you get 5, which is the factor, the dilation factor. But what is this angle? Remember, in the beginning of the session, I told you this should remind you of something. Didn't we say the magnitude is 5? So let me take 5 out and write this as 4/5, negative 3/5, 3/5, 4/5. What is that? When you have positive, negative, positive, positive, that becomes 5 times cos theta, negative sine theta, sine theta, cos theta. And since I have negative in the first row, it means counterclockwise rotation with an angle, rotation with an angle theta, whose arccosine is this number, or arcsine is that, or if you divide them, you get the arctan. So let's see what is theta. That's it. So this vector, I stretched it 5 times to a length of 5 root 2 and rotated clockwise, counterclockwise, meaning in this direction, approaching the 0 through an angle inverse cosine 4/5. What is that? 36.8. But the original angle was 45. So when I rotate counterclockwise, meaning I decrease it by this amount, what do I end up having? 813. Wow. So when you end up with a complex eigenvector, eigenvalue, and complex, of course, eigenvectors, it means that you had rotated, not just stretch and rotated. With a negative sign here, it means counterclockwise. If that was the negative and that was a positive, it would be clockwise. Well, if I don't end up with, if both of them were positive, right, it means that I must have multiplied by something here that has a 1 and a 0, and anyway, you will be 0 degrees. I don't rotate at all. Anyway, so someone can tell me, but you know what? If I have negative or negative I v1 equals v2, couldn't I have like, or to better see what I want to tell you. Now let's go to the second. Let's go to the second eigenvalue, okay? And say, let's multiply 4, negative 3, 3, 4 by oh, we haven't done that yet. I'm sorry. So for the eigenvalue, let's try to do it here. For lambda equals 4 minus 3i, these would be 3i negative 3, 3i times xy equals 0, 0. So you would have gotten 3i x or x1 minus, meaning I move it to the other side, it becomes 3x2. Dividing by 3, you will get x2 is 1. Remember, I prefer to, I'm sorry, x1 is 1, and x2 is I times 1, so it's I. 1 and I. 1 and I would be here. Of course, this would be 90 degrees because this angle would be 45 degrees here, 1i. And if I multiply that by 1i, I get 4 minus 3i, or in our language, 4 minus 3, right? And 3 plus 4i, or 7. Now, this is a slope of 7. So the angle theta here, or the angle that this vector will end up being at, would be here. But what is the angle whose tangent is 7? In fact, it would be the complementary angle of that, right? 7. I get 81, 87. This angle is 81, 87. If you subtract 45, because it was 45 that it increased by 36, 87 again, which is the same angle whose tangent is 3/4, right? So not 3/4, 4/5, I'm sorry. Its tangent is 3/4. Anyway, so the tangent of the complement. Why I'm keep saying weird stuff. I hope I didn't confuse you. So this is 45 minus 36.87. This is 45 plus 38.87 because we are rotating counterclockwise. Okay, so now we prove that really when the eigenvalues are complex, you are rotating, not only stretching or shrinking. Now, let's take another example for clockwise rotation. So let's make that number positive. So let's say 1, 2, negative 2, 1. Okay, so we know it's the same shape as cosine, sine, negative sine. However, this has a square root of 5. So this is similar to saying square root of 5, 1 over root 5, 2 over root 5, negative 2 over root 5, and 1 over root 5. So we will be stretching by factor of root 5 and rotating clockwise with an angle whose tangent is 2, or cosine is 1 over root 5, or sine is 2 over root 5. So let's do it quickly and see what we get. I would have 1 minus lambda, 2, negative 2, 1 minus lambda equals 0. Lambda minus 1 square is lambda square minus twice lambda plus 1 minus negative 4 plus 1 plus 4 is plus 5. So lambda equals negative b plus or minus the square root of b square minus 4ac minus 20 over 2. This is negative 16. Square root of negative 16 is 4i. 2 plus or minus 4i over 2 is 1 plus or minus 2i. Let's do both eigenvectors now, because last time I did only one and I thought I had them both. So we can say here, let's say for lambda equals 1 plus 2i, I will get the matrix would be 1 minus 1 minus 2i, 2, negative 2, negative 2i times v1, v2 equals 0, 0. So I get negative 2i v1 plus 2v2 equals 0. I divide by 2, move the v1 to the other side, so I get v2 equals I v1, right? Because that would be, both would be positive. So basically I have 1 and I. Wow, similar to what we had before. It's because the difference is 1. Maybe I should have picked other numbers, but it doesn't matter. We are just showing work. Okay, so now 1i again is a vector that makes 45 degrees with the horizontal in the first quadrant. Now, if I take my original matrix 1, 2, negative 2, 1, and multiply it by 1i, I get 1 plus 2i and negative 2 plus I. If you think about it, this is similar to saying 3 and negative 1. If we just say the I is like y, you know, it's just a unit. So 1 plus 2 is 3, and negative 2 plus 1 is negative 1. Meaning, now I'm rotating clockwise. And since I have a negative y, I mean I will end up in the fourth quadrant. I will get something like that. The length of this, again, was root 2. The length of that is the square root of 9 plus 1, which is root 10. Root 10 can be written as root 5 times root 2. So it's root 5 more than root 2. So this is the factor of dilation. it stretched by a factor of root 5. But at the same time, it had a clockwise rotation through an angle whose tangent is 1/3. Or negative 1/3, right? So what is the angle? Arctan is negative 1/3, or just 1/3 as a magnitude. Wait a second. Did I do that correctly? If we are rotating clockwise, I should end. I get negative 1843. Really, I am here. This angle, it's below, that's why it's negative. It should be 1843 degrees. Let's see what is the tangent of 2. Is it 45 plus 18 arctan of 2 that we rotated about clockwise? Yes, 6343. Again, if you subtract the 45 from it, because that we went from positive 45 to 0, and then another 18. So if I subtract 45, I sure get the same angle, 18 degrees 43. And to complete the work, let's look at when lambda is 1 minus 2i. So when you subtract, you get 2i2 negative 2i times v1, v2 equals 0, 0. So you get 2i v1 plus 2v2 equals 0, dividing by 2, moving v2 to the, or moving I v1 to the other side. I get v2 is negative I v1. So if I say the v1 is 1, this would be negative I. Unfortunately, I'm sorry, it's the same as the last problem. We get the same eigenvector, but the idea is clear, is that when you multiply, you will end up with, you multiply the original matrix 1, 2, negative 2, 1 by 1, negative I, you get 1 minus 2i and negative 2 minus I. Or as coordinates, this is negative 1 and this is negative 3. So now 1 and negative 1, I started here somewhere, okay? 1, negative 1. And this angle was 45 degrees. I ended up with negative 3, negative 1, meaning I ended up with in the third quadrant, right? And the tangent of this angle is arctan of 3, negative 3 over negative 1. It's 7157. Meaning if I add the rest of that to the 45, notice this is 45 below the horizontal. So if you rotate another, so this whole angle is 45 also. Now, if we subtract this from 90, and then we'll see what happens. So 90 minus that, it means this angle is 1843, the same as that one. So I rotated 43 and another 1843, which again would be the arctan of 2. Arctan of 2 was the 63. The sum of 18 and 45 is 63, 63.43. So I will end up in the third quadrant with a length of vector equal to root 10, which is root 5 times the original length, and I rotate it clockwise an angle of 63.43. So that shows you that having a complex eigenvalues, it means there is a dilation as well as a rotation. And notice that this without the negative sign is a symmetric equation because you say cosine, sine, negative sine, cosine. Of course, you don't have a sine of 2, but if you factor out the dilation factor, you end up with that. And sure enough, if you take, we didn't do that, but if you take the inverse cosine of 1 over square root of 5, not 2, what do you expect this angle to be? The 18, the 63.43, right? Which is the sum of 45 and 18. Or you could have taken the arc sine of 2 over root 5. Of course, you get the same exact result. Okay? I think that's it for today. I hope, it wasn't confusing. I think, I was going fast on some parts, but hopefully you got that. If you have any questions, any comments, please don't hesitate to leave me a note in the comment section. I keep saying comment session. I don't know what the comment session is, but hopefully I will get back to you as soon as I can. Otherwise, I hope to see you soon. Have a nice day.